Hi everyone, this is Shiva Veeram signing in. In today's session, I am going to explain you regarding the DC load line analysis of transistors. The objective here is to evaluate the Q point, also known as quiescent point, also known as operating point. So let me go through the details. In order to have the analysis of transistor DC load line analysis, we have to consider the circuit diagram. Let me explain you the circuit. Here VCC is the input voltage in the collector circuit, and similarly VBB is the input voltage in the base emitter circuit. We are going to consider the output on across RL or RC, and if you apply Kirchhoff's voltage law here at the output side, we are going to get VCC is the voltage, and this voltage will be equal to the drop across this resistance RL or RC plus the voltage VCE. So you can write down the equation as VCC as equal to VCE plus IC into RC. So let me write down the equations here. So VCC is equal to VCE plus IC into RC, and from this equation, if you write down this for IC, we are going to have IC as equal to VCC minus VCE divided by RC. So finally, if you divide the denominator to these two terms, we are going to have IC as equal to minus VCE by RC plus VCC by RC. And to consider this load line analysis, we have to have the output characteristics of the transistor. Means we have to consider the variation of the output voltage VCE with respect to the output current IC. So here, these are the output characteristics which are being considered here. VC is the output voltage on x-axis, and IC is the output current which is considered on the y-axis. So this is the input and the output voltage, and this is the output current. Here, if you consider on x-axis and substitute IC is equal to 0, because on x-axis the y coordinate will be equal to 0, and if IC is equal to 0, we are going to have, see here, if IC is equal to 0, we are going to have VCE is equal to VCC. Means for a magnitude of VCC, the value of IC will be equal to 0. Hence, the point B here, this is considered as this point B. So this is the point B here. This point B will be equal to VCC. From this equation, you can directly find out. Similarly, on y-axis, if you consider on y-axis, the value of VCE will be equal to 0. So if you substitute in this equation VCE as equal to 0, then we are going to have ICE as equal to VCC divided by RC. So here, this is the point A which we are going to get at which the magnitude of VCE will be equal to 0. And let us consider this point as A, and if you join these 2 points A and B, we are going to get a line which is known as the DC load line. And this is one of the important things which is going to decide the Q point or quiescent point, which is also known as operating point. So the selection of this operating point is very much important in order to have the faithful amplification. Okay, so these things already we have seen. So here, this is how we are going to get the operating point Q, and by joining these 2 points A and B, we are going to get the DC load line. And generally, the values of collector current IC and collector emitter voltage VCA corresponding to the zero signal conditions. Means when zero signal means when we don't give the signal. So let me again brief you the quiescent point. It is actually a point on the DC load line which is going to represent the collector emitter voltage VCE and the collector current IC in the absence of AC signal. So it is also known as operating point because the variations in VCE and IC take place about this point when the signal is applied. Generally, the best point is considered the midway between the cutoff and saturation points. That is, VCE is considered as half of the VCC. So this will be the better position of the Q point. Generally, that is being considered. So that's all for today's session. So please do subscribe to my channel and give your valuable feedback so that I can do much more videos for you. Thank you very much. This is Shiva signing off.